All right, so today we are talking about Venn diagrams for the most part, and mutually exclusive events. Exclusive means set apart. It means like really special. So for instance, if you go to an exclusive restaurant, that means that it's probably going to cost like 50 bucks per person. It's going to be really fancy. You guys been to the Melting Pot? Raise your hand if you've been to the Melting Pot. All right, that's what I would consider an exclusive restaurant. Was it cool? Did you do like a lot of people are doing like birthday parties and that kind of stuff there? Is that what yours was, or anniversary for Grandpa? Okay. Fogo de Chao, yeah, that's another exclusive restaurant. I have not been there, but I've heard it's amazing. Is that the one where they have the meat? Basically, you put out the little thing and then they come around with meat. Who has been to Fogo de Chao? Two of you. All right. Any other fancy restaurants that you've been to? There's another one called the Ocean Air. Anybody ever been to Ocean Air? That's a cool one. Seafood, right? Lots of really good seafood there. Another one is Manny's Steakhouse. Been to Manny's? That's a really good one. That's got great big hunks of meat that they bring out, and you can pick. Like I went that one, and then they fry it up for you, or do whatever, you know, put it on the grill for you. They have lobsters and stuff too. So anyway, exclusive means like really separate from, because it's like better than other places. All right, so these are mutually exclusive, as in both separate from. Mutually exclusive means separate from. So boys and girls, you can't be a boy-girl. Okay, we all know it's possible. There was a runner in the Olympics not too long ago who was a female and was running in the races and was winning by like this huge margin, and she just looked like she could be a guy. And I mean, at some point they have to question, is there a chance that this person has an unfair advantage over the other competitors because they're actually a male? And they're just saying they're a female. So the person submitted to a doctor exam, and the doctor used a ultrasound. You know what that is? Where they can like see inside of you. And they found out that she never knew this, but she had both parts. She was a female on the outside, but she was a guy on the inside. And I'll let you figure out what that means. So anyway, she had a lot of testosterone, which gave her a big advantage in these races. So I know there's almost always an exception where there could be an overlap. All right, but in this case, we're just saying that you really can't, and it's just either boy or girl. All right. So if we did other examples of this, it might be flipping a coin because it's either heads or tails. You don't usually allow for that other option, which is possible, which is what? Stands on its side, because you can make a coin stand on its side, but it's just almost impossible to flip a coin and make it stand on its side because it's bouncing around too much. Rolling a die. You're only going to get 1, 2, 3, 4, 5, or 6. I suppose a die could end up like laying on its side on a truly flat surface. I don't think so, but maybe. All right. Mutually exclusive is different than this. This is not mutually exclusive. This is where things overlap. Okay? And I think one of the best ways to do this is to actually make one. We're going to do iPod versus dog. How many of you guys have a dog but not an iPod? Raise your hand if you have a dog but no iPod. 2 people. All right. Who in here has a dog at home and an iPod? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Who in here has an iPod but not a dog? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Who in here is that special person that does not have a dog and does not have an iPod? Anybody? So that's weird. So everybody in here. If there had been somebody, we'd have put them down here, but we don't have any, so we don't. Would you please fill in these numbers quick on your screen? Or on your piece of paper if you're one of those cavemen. All right. So now, if we did the same thing except made it the probability Venn, what's the difference? Well, these were just numbers of people, like how many are there, and there were 29 of you. And down here, I would need to change it into probabilities. It's pretty simple. What do you think I'd do to figure out the dog percent that should go in there? All right, so it was out of 28, so you'd take... This is 29? Oh, sorry, 29, so it's 2 out of 29. Would you please divide that quick? You have a calculator on your iPad. See what decimal it comes out to be. We'll always use 3 decimal places, so 2 out of 29. Once you have your calculator up, it'll be easy to use the 4-finger swipe to go between the apps. You know what I mean? You could go from your notes to the calculator with a 4-finger swipe. All right. 2 divided by 29, what'd you get? Point what? 0.06. One more number. 9. And is the next number also bigger than 5? A 5 or bigger? All right, so then that's going to actually round up to 0.070. Oh, no? Well, the 9's been rounded. Okay, thank you. All right. So next thing. I could take each of my numbers and do this. Let's not, because it'll just waste time. 18 out of 29 goes here, and it's easy to do. 0.6, okay, as long as somebody's doing them. 0.621, and what's the last one? It'll be 9 out of 29, which is 310. Thank you. Okay, that's a 0, because there weren't any kids that had that situation. All right, so now, let's talk about probabilities here. If I wanted to toss a coin over my shoulder and somebody ends up getting it, what's the probability it would be a person who only has a dog? Well, I just look at this. That's really easy. 0.069, about 7% chance of that. Okay? But here's where it gets more complicated. When I say and or. All right, so if I said, I toss the coin to a person who has a dog and an iPad, or iPod, sorry. Dog and an iPod. Now, does that mean this and this and this, because the word and sort of implies that? Or does it just mean these people? What does and mean? Here's the way I think it makes the best sense. If I talk to these people, and I ask them, do you have a dog and an iPad, or an iPod, sorry, what would they say? No, they would say, no, I don't have a dog. If I talk to these people and said, do you have a dog and an iPod, what would they say? Yes, so it's these people. It's not these people either. They would not answer yes to the question. Do you have a dog and an iPod? All right, so and just means the one in the middle. How about or? That's the most common misconception, besides that or is this or that. And it makes sense, you know, this or that. But if I ask these people, do you have a dog or an iPod? What would they say? Yes. Therefore, they're included. So or means all of them. All 3 of them. That's really easy to forget. So or is the bigger answer. And questions, those give you a smaller answer. Because you have to have a dog and an iPod to qualify. You get that? All right, let's do one more. Get to a new page here. Go to the cats, dogs one. It's always fun to see who's a dog person, who's a cat person, and there's always a few people who have both. So, who's a dog person? Raise your hand if you have. Now, this is to clarify. You have a dog. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And why is that information useless? Yeah, because I didn't ask about the cat thing. Because, see, there's 20 people that have a dog, but I know this and this together have to add up 20, but I don't know what they are. You get what I'm saying? All right, who has only a dog and does not have a cat? All right, what would be even smarter? Hands down. I should instead, if I know the total is 20, I should probably ask this one, because there's not going to be many people who have a cat and a dog, right? So who has a cat and a dog in here? Do they get along? Curious. Do you get along? Do your cat and dog get along? Sometimes. That's exactly what happened last hour. One of the two people said they get along great, and the other one said, yeah, sometimes the dog's biting the cat. Is it usually the cat winning or the dog winning if they get in an argument? The cat's just hide? Okay. All right, so there's two people here. So if I knew there was 20 total, then what should I put there? 18. All right. And now how about cats? Who are the cat people? You have a cat and not a dog. 1, 2, 3. I'm winning that group too, but I'm not going to raise my hand in this one. But I have a cat and not a dog. I used to be a dog person my whole life, and then we got this cat, and I just love this cat. He's such a good cat. So friendly, jumps up on you, and what? So we have to now do the neither, right? Okay, so who's no dog, no cat? Raise your hand if you're no dog, no cat. 1, 2, 3, 4, 5. Now, don't worry about how that might not have added up to the exact same number of people as last time. Maybe I counted wrong. Maybe somebody doesn't want to answer, and I'm not going to make a big deal out of it. Okay. So now, here's a typical question. What's the probability that if I taped an envelope underneath somebody's desk in here, that if you reach underneath and it turns out to be you, that that person would be a person who has a dog or a cat? Do it. Figure out the answer. Divide it as a decimal. Tell me what it is. A dog or a cat. That's a good question. A dog or a cat. If I ask these people who have both, do you have a dog or a cat? They'd say yes. All right, so hopefully you added up 23 out of the total of 28. Is that what you were dividing? Raise your hand if you were dividing it correctly. Okay, good. All right. How about and? What's the probability that it would go to a person who has a dog and a cat? Be 2 out of 28, right? Okay. All right, moving on. This is a chart that's already been done. Can you tell, is it a frequency venn or a probability venn? Probability, because frequency, there'd have to be only 0.4 of a person who has only math. And that doesn't make sense. But 40% of the group, that makes sense. All right, does this chart likely to be close for our schools? Situation? Tell me why not. Because pretty much everybody's taking math and science, right? Is there anybody in this school that is not taking math or science? Yes, but it's rare. They are usually a senior who's already got all their math and science credits. Or they're a kid who's really bad at math and it was failing the class, and so they dropped it and they plan to take math again next year. Yeah, but it's really rare to have somebody not taking either. And if you're taking math, you're pretty much taking science too. So these numbers would not be logical for our school. But all right, so what do each of the 4 regions represent? Well, these are people that are doing math but not science. These are math and science. And this is science but not math. And this is neither one. That's what they represent. Now here's the main thing that you need to learn from this. If I said math and science with symbols, I'd say probability of math and science, and if I want to say and, there's a symbol for it that you need to learn. It's either this or this. One of those means, what do you think one of those means? You could guess. Union, very good. And which one do you think means union? The U, that makes sense, right? And union means like a big group all together, all of us together in this union of the United States of America, okay? That's what union means. So union would be like all of these. So union of math and science is the same as what? What word? Or. would you please put this little symbol by the or, because you need to remember that when they say that, they mean or. I know it seems like it should be and, but it's not. Remember, and is the small answer. Or is the big answer. And or also goes with you. So it's the bigger answer. This one does not mean or, it means and. It means the smaller answer. And there's one more word that we use for this, intersection. There's union and there's intersection. The intersection is where they overlap. Think about that. Where do they overlap? Right there. And isn't that a smaller answer? Yeah, it's only one thing. All right? So intersection also, we talk about it a lot with streets, right? Let's say this is Highway 7 and this is Highway 101. You know where the intersection is? It's right there. So if they were going to put a symbol in the intersection, they should put intersect. But then the problem would be if you're reading it from the one direction, it would mean union. And if you're coming from the other way, it would be an intersection. If you're coming from the side, it would look like a horseshoe. But anyways, okay, so intersection. This is the intersection. If I wanted union, what would I need to do? The union of 7 and 101. That means all of 101 and all of 7. That's the union. We've never talked about streets that way before, but you've heard of intersections all the time. It's where they cross. Okay, union is all of it. All right, so why do you care about this? Because in a typical problem, they're going to give you this. M-U-S, or M intersect S. That's an intersection. I like to think of the street example. So, there's your answer, 0.3. Okay, because it means intersection. How about if they said M-U-S? Probability of M united with S. It's all of these. Does include the middle. Oh, not the neither. Not the neither, though, because that's not part of the group. All right. All right. What if they use the word or? Remember, that's the same as which symbol? The U? Yeah, it is. So it's like this. So that'd be all of them. Or is the big answer. Okay? All right. Oh, one more thing. This is kind of important. Suppose the diagram refers to a group of 100 students that were polled. Well, then it's really easy. And it's 40% of it, so this would be 40 kids, and this would be 30 kids, and this would be 20 kids, and this would be 10 kids. But that's really easy because it's 100. What if it's 848 kids were polled? Exactly. You just take 0.4 and you times it by 848, and that'll give you what number of kids they got there. Get the idea there? Okay, so if they give you a probability venn, that's this kind where it's got percents in it, and they ask you how many kids were science only, well, you go 0.2 times however many kids there were. You just multiply. At our school, it would be like 96% of the kids taking science, and there's 2,800 students here at Minnetonka High School. So you'd multiply those decimals together. All right. That's how you do that kind, and I think that pretty much wraps it up. So your homework for today is the one on probability. It's technically called section 12.3. So you're looking for worksheet 12.3, and I think there's an A and a B, and you want 12.3A. That's your homework. Plus one other little thing. 15-second video. Tell me about yourself. Tell me something that I might, some of you that I've already had for a semester, tell me something I don't know. Like, you may not know that I'm really into Britney Spears, or whatever.